So what I'm trying to say is that the Bitcoin mindset is not payments. It's not about Bitcoin payments. It's about our ability to transfer value exactly like we would transfer value using cash. So Bitcoin is the reimagination of cash in a digital world. Because when you make a Bitcoin transaction, it's not an instruction. You're actually sending the value, and you're not relying on any third party to facilitate the value transfer. And it can transfer from anyone, anywhere, at any time. And that's completely different than payments. And the value proposition of Bitcoin, what I feel, lies on the use cases that value transfer can unlock. So imagine we have a native currency to the internet that can facilitate the value transfer anywhere, anytime, by anyone. How many use cases that can unlock?
First, indeed, is Bitcoin lending. I think the ability to use Bitcoin that is appreciating 30-40% per year to actually get liquidity without selling it, I think is a very crucial use case. And right now, either you go custodial to get good rates or need to bridge to another chain to use like so-called lending pool, DeFi, somewhere else. But again, you're degrading your security of your Bitcoin, right? So, and even more importantly, it's not only the security of Bitcoin, but your own UTXO. You want to know where the UTXO history is coming because maybe you took sort of block of time, maybe you mined, you don't want to mix with someone else. So it's very important to have that UTXO ownership, and having this is very important. The second use case I'm very interested is the concept of non-interactive swaps.
And so then you think about the amazing renewable resources on the continent, which produces very cheap electricity. It means that we can mine Bitcoin in Africa at a fraction of the cost of anybody else in the world. So not only can we drive more Bitcoin mining in a more decentralized fashion, but we can do it with better unit economics than anybody else in the world.
Hello, everyone, and welcome to the Plan B podcast. I'm your guest host, Stephan Livera, and I'll be chatting with my guest today. My guest today is Philip Walton. Philip is the CTO and co-founder of Gridless, a really interesting company, and interested to get into this and hear a little bit about Philip's perspective on building in Africa and Bitcoin mining and all the rest of it. So I guess just give us kind of a quick kind of summary, kind of your bio. What have you done before you came to Gridless and Bitcoin mining?
Yeah, sure. So my co-founders and I have been building tech businesses in East Africa for 20 years. So a variety of different sectors. And we started Gridless back in 22. And we're specifically looking at this challenge in Africa where there's a tremendous amount of energy that has no buyer. So the energy is being produced, the community can't afford to buy it. And so we started thinking about like how could we monetize that energy? And very obviously Bitcoin mining is a great use case. We had the background in building, complex infrastructure in remote parts of Africa. And so that was really the genesis of Gridless. And for the first few years, we focused on existing energy sites.
And sorry, by the way, what year did you start?
22.
22, okay,
yeah,
fantastic.
22, yeah. So we started focusing on existing energy sites. Some of these sites were 15 years old and had never sold more than 30% of their electricity. So their economics were in the toilet, like they could not survive. And the fact that we can show up with a container of Bitcoin mining hardware and instantly monetize every electron of electricity that nobody else will buy revolutionizes their economic outlook. So we're currently in 6 sites in 3 countries, so Kenya, Malawi, and Zambia. And we're currently on a massive expansion across the continent.
Now, my first, topic that I think I'm curious about and probably listeners will be curious about is the why Africa question, right? Because a lot of people might have seen the Bitcoin mining world and thought, oh, but there's already like very established areas, like what about Texas or or China, right? What about these other kind of areas where it's kind of a very well-established business as opposed to Africa?
Yeah, so I think there's 2 facets to that. One is why did we do it in Africa? Although I don't look like it or sound like it, I'm from Africa, and so are my co-founders, and so. For us, we're always looking for problems we can solve at home, and so like for us, it was more about what problems can we solve in Africa than necessarily here's what we want to do, let's go to Africa. But I think the other side of that coin is, Africa's, this is a horrible stat. I like, it actually makes me sad every time I say it. The International Energy Agency did an assessment 15 years ago, and there were 1.2 billion people in the world without access to electricity. 600 million were in Africa. Fast forward to 2024, there are 800 million people in the world without access to electricity. 600 million of them are in Africa. So we have this massive challenge on the continent that there is half of our population that does not have access to electricity. And so then you think about the amazing renewable resources on the continent, which produces very cheap electricity. It means that we can mine Bitcoin in Africa at a fraction of the cost of anybody else in the world. So not only can we drive more Bitcoin mining in a more decentralized fashion, but we can do it with better unit economics than anybody else in the world.
That's fascinating. And so I guess in order to understand this, part of that is understanding there's a difference between, let's say, energy generation and then the transmission component of that. Because, in, let's say, most of the Western world and the developed, like a highly developed world, people just sort of, switch the light and, the light turns on, right? Can you just maybe articulate the difference there for people to understand why this business model works?
Yeah, so it's I'd actually explain it a little bit different. In the Western world, there is always a buyer for any unit of electricity produced. So most of the Western world has real-time energy markets. So if I'm a producer of electricity, if there's a lot of demand, I get paid a high price. But if there's low demand, I get paid a low price. But I always can sell my electricity. Shift that over to Africa, and like one of our sites is in northwestern Zambia. If the community is not buying that electricity, there is no other buyer, zero. So there's no market for that electricity. And so that creates this, massive black hole of economic opportunity because that electricity, Janet, my co-founder of Gridless, says the river doesn't sleep at night. So the community's asleep, they're not using electricity, but the river's still flowing. And so all of that electricity, in essence, is wasted. And so it creates this very unique opportunity that we can, because of the geographic agnosticism of Bitcoin mining, we can put Bitcoin mining wherever the energy is being produced, and then anything the community doesn't want, so we always give to the community first, but anything that they don't want, we can instantly monetize with Bitcoin.
So we've touched on this idea of mining Bitcoin, but also advancing energy access. So could you elaborate a little bit on that? How does that process work?
Yeah, so today, if you see an opportunity, let's say you find a community that doesn't have electricity, and you find an energy source, so it could be hydro, it could be solar, it could be wind, it could be geothermal. That requires millions of dollars investment to build that energy. That community cannot repay you those $1 million of investment. Like there's not enough economic turnover in those communities to repay that investment. And so what ends up happening is, people with good intention, usually with concessionary funding, will go in and build these energy sites because they're trying to serve the needs of energy access. But ultimately, there's not enough revenue to repay that investment, and they economically fail. I mean, the failure rate of mini grids in Africa is approaching 100%. It's a shocking statistic. Like there's just not enough demand from the community. So think about this. If I were to come to Lugano and build a new energy site, there are a variety of industries and factories and consumer demand. But if I build new energy in a rural African community, people are going to do two things. They're going to charge their mobile phone and they're going to run an LED light. It's just not a massive consumption of electricity. Now, over time, they will use that electricity. But, this in Bitcoin world, we talk about low time preference, And so as an energy developer, if I'm expecting that community to repay my investment, I have a high time preference. Whereas if I go and build that energy based on knowing that Bitcoin will buy everything that nobody else in the community wants, I now have a low time preference for that community to take up the utilization of that energy. And so I'm not pushing them to buy more. I'm not raising the cost of electricity to try and recoup my investment. I simply can go in there, build the energy, let Bitcoin be the buyer of first resort, and as soon as the community wants a little bit or a lot, then I sell it to them instead of selling it to the Bitcoin network.
It's interesting how the economics of this change the game in a certain way. And so, I guess, do you have any examples or stories you can share of, let's say, people or communities that have been changed by this kind of model?
Yeah, listen, it's an amazing statistic, but as I said, we're at 6 sites in 3 countries. In the last 2.5 years, 30,000 people have gotten access to electricity because of Bitcoin mining. Now,
that's a cool stat.
That's a great stat, and that's real impact. The reason is not because we enabled the energy to be developed. The energy was already there. The reason is because we made that energy economically viable, which meant they could afford to pay their salaries, they could afford to run more distribution lines, they could afford to buy more meters to connect more households. And so it really is one of these things that there's almost like this economic roadblock that exists if you get concessionary financing, like from a DFI, to build a power plant.
Sorry, what's DFI?
Direct foreign investment. So CDC or CETA or the old USAID. So they'd get funding from one of those organizations, they build a power plant, and then the community wouldn't buy enough. Then they don't have cash flow, they can't pay the salaries, they can't maintain their distribution lines, and there's a decline in the quality of service. Whereas as soon as, and when I say as soon as, the site that we did in Zambia, so they're 15 years old, we took we build mining containers in Nairobi. We took a mining container from Nairobi, drove it 2,000 kilometers through the African bush, deployed it, installed the miners. The next morning, the energy company got paid. That's for them, that was an amazing step change in their economic future, because now they have real cash flow that enables them to then focus on the things that actually impact the community. More lines, more meters, more resources. And so that's really to me, that's the power of Bitcoin mining as an enabler for energy access.
Now, my next question is around technical and logistical challenges. You touched on this in your recent answer, where you were saying you had to move this equipment. Like you've got to have mining equipment. You need technical expertise. There's operational challenges. Can you elaborate a bit on that in the African environment?
Yeah, it's hard. We often have this conversation. People are like, well, why don't you have competition? It's like, because it's hard. Like, it's not easy to go deploy technical infrastructure into a very remote rural location. We're super fortunate that, in previous businesses that we've built, we've done this. Like, we know how to build, sophisticated infrastructure that's remotely managed, that's deployed in remote locations. And so, we've been able to take advantage of that experience to be able to do this. But in general, when we deploy a mining container, it is lights out. So the mining container runs completely automated with no human interaction. We use a combination of Starlink and local LTE service to provide the connectivity. But then the administration of that site, like managing the site, monitoring the site, all of that's actually done from our office in Nairobi. And then we tend to send resources on site maybe once a quarter to go do maintenance to the machines, resolve any issues that have cropped up. But I think it's one of the things that if we hadn't been able to solve that, there's no way we could do what we're doing.
Right, so I guess the answer is it takes technical, operational expertise to handle the challenges.
100%, yeah.
Now, I guess the other point people might be thinking about when it comes to this is things like, well, Bitcoin mining machines have a useful life. And eventually, they, because of the increase in the price, the rise in Bitcoin hash rate, difficulty adjustment, et cetera, the rigs kind of run out of useful life. So what's the plan in that context? Like, does that mean in the 5 or 6 years, Well, I guess, can you explain the useful life concept and then what you do with that?
No, it's a super important point, and it's something that I think that we, like if you look at the Bitcoin mining space, Gridless has a very different view on this than the traditional, industrial Bitcoin miners. Most industrial Bitcoin miners are paying a fixed price for electricity. So if you're paying 5.5 cents for electricity, there's a certain amount of revenue that you have to get, or your economics don't work.
Or maybe said another way, the price of Bitcoin needs to be above this level. So this
is actually interesting. If you look at the economics of Bitcoin mining, it is largely decoupled from the price of Bitcoin. And it really comes back to the cost of energy. So Bitcoin mining is really an energy arbitrage. And yes, when there's a spike in the price of Bitcoin, the revenue for Bitcoin mining will go up, but it quickly adjusts back down to a range.
Because of difficulty adjustment.
Exactly. And then conversely, if there's a drop in the price of Bitcoin, it adjusts back up. So I did this comprehensive analysis over the last 8 years, and the range, so if you just think in energy terms, so don't care about the price of Bitcoin, Bitcoin mining pays between 7 and 11 cents per kilowatt hour, adjusted to kind of the current average efficiency of machine. And the peak of that histogram is 9 cents. So when you start thinking about it that way, all of a sudden I can take an older machine. So like right now we're running, kind of some last generation machines. They're generating 7 cents a kilowatt hour revenue. But here's the catch. I'm not paying for electricity. So we do a revenue share with the energy company. So even if that price per kilowatt hour was to go down dramatically, I can still mine profitably. Whereas, to a Western miner that's paying 5.5 cents, if their revenue drops to 6 cents, they have to turn off their machines. They cannot afford to run them. And so that gives us a huge advantage, from a global competitive standpoint, that we can run older mining machines longer in Africa because of the economic structure and the cost of our energy.
Yeah, it's a fascinating model. And so can you maybe outline a bit, and I guess you're touching on it in your answer there, because I guess a lot of people talk about in terms of the operational cost, but there's also kind of an upfront capital cost if you're buying a lot of mining rigs. But to your point, you're buying the older stuff. It's cheaper.
100%. No, so this is actually funny. So I actually maintain a spreadsheet that looks at the cost per terahash versus my gross margin per terahash. And the truth is that buying an older, let's say 30 joules per terahash machine at $2 a terahash is better for me economically than paying $12 per terahash for an 18 or 16 joules per terahash machine. So the truth is that we actually get, again, a huge competitive advantage that we can buy less expensive older machines, so therefore we're putting less CapEx into that site. But if you look at my gross margin per kilowatt hour, it's as high or higher than the guys running the latest machines in the US. So, I love Adam Smith. I love the labor theory of value. I think about it as the energy theory of value. Like ultimately, this is a globally competitive marketplace, and whoever has the best arbitrage, that's your competitive advantage. And so it means as Bitcoin miners in Africa that we can globally compete with everybody else in the world doing Bitcoin mining, and we can have an economic advantage that allows us to be the cheapest producer in that globally competitive marketplace.
Yeah, I find that fascinating because it's like you're sort of flipping certain models on their head in a way. You're sort of saying, well, we don't need to actually have the latest and greatest mining machines. We can actually work with some of the older ones because the cost efficiency of it works out better for us, theoretically.
Yeah.
Well, in practice, sorry.
No, in practice.
And I guess then the other question people might be thinking is it just like a question of scalability? Like it's hard to go out and make lots of new sites, and that's kind of the challenge for you?
100%. And like you hit the nail on the head. So the challenge for us is the existing energy sites are finite. in terms of like an operator that's already running, that has wasted electricity. And so we recognized about a year ago that we needed to vertically integrate mining and energy generation. And so we're currently in a phase of growth where we are buying existing energy sites, integrating Bitcoin mining, and then we're starting to develop new energy sites. So we're building new energy sites from scratch based upon this Bitcoin economic model. And that, as entrepreneurs, that gives us the control, right? So it's now all within our control to accelerate that expansion. And we're not dependent upon somebody else that's like found themselves in a tough spot and needs our help. And the truth is, if, like Africa is insanely rich in energy resources. Like, it is shocking that the poorest energy country on the planet is the richest in energy resources, particularly renewable energy resources. So if you look at just hydro alone, there's 400 gigawatts of untapped hydro on the African continent. And if you were to bring in solar and wind and geothermal, it's probably 10 times that. So the truth is that there is an abundance of cheap energy resources on the continent, but there's never been an economic model to go develop those at scale until now.
And so you touched on this idea of creating energy grids or mini grids. How does that balance with, I guess, the cost of getting Bitcoin mining? I guess you just kind of have to factor it all together of like, okay, here's my plan for this site. This is how much it's going to be for the grid, and this is for the mini grid part of it, and this is how much it's going to be for the Bitcoin mining part of it. Is that how you see it?
Yeah, no, it's interesting. So we actually think of Bitcoin, the Bitcoin network, right, the energy buying side of the network, as a market maker for the value of a unit of electricity. So if Bitcoin is paying me 7 cents per kilowatt hour, and the community will pay me 8 cents, I'm going to sell to the community. And if you look historically at mini grids in Africa, the price for electricity is often close to $1 per kilowatt hour. So I can go in and say, look, Bitcoin is my market maker. So Bitcoin's paying me 7 cents, I'll sell to you for 8 cents. And that's going to be the cheapest electricity that anybody in that country has access to. So we really get this unique opportunity that it is both good for the community, and it's in our financial best interest to sell as much as the community wants, as long as it is just marginally more than what Bitcoin's paying. But then we can always fall back on Bitcoin buying whatever the community doesn't want.
It's kind of like your fallback option.
It's perfect.
I forgot the other question I had, but all right. So, all right. When it comes to like regulatory risk, like do you see that like the nation states or the regulators of these areas, whether it's an energy regulator or elsewhere or otherwise, what view do they have on what you're doing?
It's really funny. So one, in terms of Bitcoin mining. So far, most countries, there's one exception in Africa, but most countries, even if they're violently opposed to Bitcoin, the monetary technology, are fine with Bitcoin mining because it represents hard capital coming into their country. So the great example is Ethiopia. You can come listen to our panel tomorrow. Nemo from QRB Labs in Ethiopia will be on the panel with me. And Ethiopia as a country doesn't allow Bitcoin, but they are now the largest Bitcoin miner on the African continent because they embrace that as a distinct technology from the monetary system itself. But if you think about like how the energy regulator views us, and we've seen this in Kenya, Malawi, Zambia, Rwanda, Guinea, Uganda. If we go to the energy regulator and we say, look, we'd like to come in and build new energy, and we don't want you to give us anything in exchange. We're not asking for anything from you. They always say yes. Because typically if an energy developer comes, they want the government to promise them something. Promise to buy my electricity, promise to pay me a certain amount. And so, when we're going in there and saying, look, I don't need anything from you. I'm bringing my marketplace.
Kind of just a win-win for everyone.
So I mean, in Malawi, we asked the government for a license to build a site. We got it in an afternoon. Like it's such an easy conversation compared to kind of the traditional mode of energy development.
I guess zooming out a little, are there any kind of global macro trends that impact you at Gridless?
Well, yeah. So when I saw that question, I was thinking about it. Like, I think one of the things that impacts us the most right now is the push for AI. And the reason is...
Are you going to pivot to HPC?
Well, so yes, but in the future. When you look at the demand in the Western context, particularly North America, for energy to dedicate to AI and HPC, the energy that's being used for Bitcoin mining is grossly underperforming from an economic standpoint than if that same energy was put to HPC. So you're seeing the Bitcoin miners start to shift to, they can make a lot more off their energy contract selling to HPC than they can to Bitcoin. And what that means is there's a lot of equipment that no longer has a home. And so there's a lot of that. So there's like a lot of the conversations we're having right now is how do we relocate assets from North American operations to African operations, because we can keep those assets productive, in fact, making more money than they were making in the US, and then that energy can go to the HPC.
That's really fascinating. So it's like, if I've understood you, it's like some of these big mega miners in the US and other Western countries, they are now kind of pivoting a little to AI, HPC compute. That means they may not need some of the Bitcoin mining machines, which they can sell off to you, 100%. And you guys can kind of get those a bit cheaper. All right, well, I think we're going to have to wrap it up now. So just quickly, where can people find you online? And we'll wrap it up there.
Yeah, so website's Gridless Compute. I would tell you my Twitter handle, but I don't remember it.
All right, well,
gridlesscompute.com is
well,
is
I tweeted
website.
it out, so people who want to follow can follow Philip there. That's it. So everyone, please put your hands together for Philip Walton. Thank you.
Thank you.
So we're back on for the Plan B podcast, coming to you live from Lugano. I'm your guest host, Stephan Livera, and I'm joined by my friend Roy Sheinfeld, the CEO and co-founder of Breez, well known for supporting Lightning adoption and Bitcoin adoption around the world. So let's start here, Roy. So you wrote an article recently for Bitcoin Magazine, and I think one concept you were touching on there is around value transfer instead of payments. So can you explain a bit, like, what are you getting at there?
Yeah, that's my new crusade, to try and people always ask me, okay, why would I spend my Bitcoin, right? It's all about trying to understand what's the utility behind using Bitcoin as a medium of exchange. And I think what I'm trying to convey is the fact that we're all living under a payment mindset. So in my article, I kind of define what payment is. And basically the definition I came is to say payments are instructions to settle a debt. What does it mean? So when you pay someone, you're not actually transferring value to that person. You're sending an instruction to a third party to send value to the other side. So that's one aspect where payments are different than value transfer. The other aspect is that when you pay someone, there's always a settlement. It's always an open debt that you need to settle. You buy something for a merchant, you need to pay them. You're clearing a debt. When you pay your employee, you're clearing a debt. So value transfer, and that's a very fiat mindset. Payments are fiat mindset because value can transfer in a very specific path, only when there's debt, and only through third parties that are allowing you to facilitate this value transfer. So what I'm trying to say is that the Bitcoin mindset is not payments. It's not about Bitcoin payments. It's about our ability to transfer value exactly like we would transfer value using cash. So Bitcoin is the reimagination of cash in a digital world. Because when you make a Bitcoin transaction, it's not an instruction. You're actually sending the value, and you're not relying on any third party to facilitate the value transfer, and it can transfer from anyone, anywhere, at any time. And that's completely different than payments. And the value proposition of Bitcoin, what I feel, lies on the use cases that value transfer can unlock. So imagine we have a native currency to the internet that can facilitate the value transfer anywhere, anytime, by anyone. How many use cases that can unlock?
Mm-hmm. And you touched on this idea that basically payments require bankers. Do you want to elaborate a bit on that? And I guess, look, let me steelman a little bit, because people could challenge us and be like, well, look, you Bitcoin and Lightning guys, you're making use of things like LSPs or swap services and things like that. So how and why is that different in your view?
First, you don't ask permission. Even if you're not doing, you're talking about second layers, but let's talk about kind of the value proposition on the first layer. Before we're talking about optimization and scaling Bitcoin, people need to use Bitcoin in order to facilitate value transfer. People are actually using Bitcoin in order to facilitate value transfer because no one knows how the Bitcoin flows in layer one. Now, where we come to the scaling issues of Bitcoin, and we want to facilitate value transfer for billions of users, then we get into a very complicated discussion and convoluted discussion of trade-offs. LSP is a trade-off. The ability to allow end users to connect to the Lightning Network encapsulates some form of centralization, and this centralization comes in the form of an LSP. The way to mitigate that centralization is to allow anyone to run an LSP and to allow anyone to connect to any LSP they choose to. So we're kind of decentralizing the LSP that is in itself a centralization factor. And the same is true about other layer 2 solutions like Arc and Spark, etc. I actually think that the future of scaling layer 2s is about us having multiple subnetworks, different subnetworks. Each is running by multiple operators, different jurisdictions, and Lightning is evolving from technical solution to what I call a common language that provides interoperability between all the different subnetworks.
Yeah, I think I'm with you. Like, if I were to look at the fiat system, right? You've got basically there's one Federal Reserve, and there's all these, tens of thousands of fiat banks around the world. I don't know, call it 30,000, 40,000 fiat banks around the world, and that's what most people are using today for fiat payments, aren't they?
Yes.
Now, in the Bitcoin and Lightning context, hey, you can run your own Bitcoin node, you can run your own Lightning node. There could be millions of these. Now, maybe not today, but
if someone fails, you can run another.
Right.
So it's about the optionality. It's about our ability to have an alternative infrastructure. For example, they always say, okay, people ask me, but in Europe we have open banking. So what's the difference between having a permissionless, open, decentralized network and having an open banking API? But when you dig into the open banking API, you find out that just 10 operators can operate open banking API, and you need to KYC, AML, and go through a rigid process of being approved by this open banking service provider to be able to integrate with the open banking network. And the first thing they ask you when you want to register to this open banking API is, okay, what's your volume? And if you're not like a multi-million dollar company, you're excluded from the network. So the fiat is all open banking, fintech, all this type of solution is what I call lipstick on a pig. It's just a digital facade to the same broken, permissioned, closed fiat system.
Right. And yeah, so I think, as you said, it's like there's a big optionality difference in Bitcoin. Well, of course, we encourage people to use self-custody, verify yourself, use your own Bitcoin node, all the normal, maxi things that we talk about. But the point is it's an option, even if you don't, actually do it. Of course, we encourage you to.
And everything is open source. And everyone is free to use the Breez software, for example. Everyone is free to run their own Arc. Everyone is free to run their own Spark. So
Yeah, so the freedom is out there. Now, the other big topic I know is the time to build. So tell us a little bit about, what is this time to build developer kind of hackathon competition that you're running or you're part of?
Time to build, the number 2, build.dev is something new we're trying. It's not a hackathon, it's a challenge. Because we don't want to build hacky stuff, we want to build solutions.
Real stuff.
Like my thing from the get-go was to bring Lightning to applications. The last thing the world needs is another Lightning wallet. So we don't want to build Lightning wallets. We want to meet people where they are, and we want to bring Lightning to mainstream applications. So our first attempt in kind of unlocking that is this time to build challenge, where we have a prize pool of 25K for developers that integrate Bitcoin into open source applications using the Breez SDK. We're working with over 50 communities all around the globe, Bitcoin developer communities that taking place in this challenge. We have great sponsors that are supporting us with the prizes. We have amazing judges, and everyone is welcome to contribute to an existing open source application, some type of Bitcoin functionality. So it can be, for example, adding Bitcoin to Signal, or adding Bitcoin to a crypto wallet like Trust Wallet, or adding Bitcoin to an open source social network, or adding Bitcoin to any messaging app out there, games. The possibilities are really endless. And if you're doing a good job and convincing the maintainers of the open source repositories to merge your PR, you're eligible to participate in Time to Build.
Yeah, so it's putting it into practice, and I guess there's a little bit of a tie-in with Breez SDK. So maybe some users or some participants in time to build may choose to use Breez SDK, but I guess they can use
the Breez SDK.
Yeah.
So I want people to use the Breez SDK, not because I really. That's why we also kind of name it Time to Build. The solutions that we're building are really making it super easy for developers to integrate Lightning. I don't want them to explore. I love LDK. I love LND. I love Core Lightning. I love Bolts.exchange, but I think we provide a level of polish and a level of simplicity that is needed for developers that are coming from the generic development space to interface with Bitcoin. So I want them to try the Breez solution as the first interface to Bitcoin. Yeah, so I'm pushing my own solutions for sure.
Hey, fair enough. So now let's talk a little bit about what exactly that obviates, right? Because if you are coming from the perspective of a non-Bitcoin Lightning, really deep in the weeds dev, what are some of the things that might be challenging for them? Like obviously in the Lightning context, it's things like, okay, inbound liquidity, which is the big one. And then things like, okay, monitoring channels, thinking about channel liquidity. How much liquidity do I need in the channel? How am I going to fund that? What's the capital cost? All these things. Right?
These days are over. What we're doing with our Nodeless SDK, we're alleviating the need of running a node, understand the complexities of the underlying implementation. We have partners that from downloading the SDK to production, it's a matter of days now. And we have developers that are able to create initial POCs in a matter of hours. So it's super simple. The days of nodes, channels, liquidity, offline receive are over. It's time to build, and any developer can interface with Lightning right now. The problems that still remain are not specific to Lightning. It's the seed management issue that it's still challenging for mainstream users to interface with, and on-ramps and off-ramps. I think that's kind of the two biggest challenges.
And to some extent, people are going to use like USDT as like a on-off ramp, or to kind of smooth that process, even if it's, there are certain trade-offs with these, of course. So can you just outline the various forms, because as I understand, like in the early days of Breez SDK, it was the Greenlight style, and as I understand now, you have the Nodeless style, and that started with a more, let's say, liquid Bitcoin, LBTC-based form, but now you also are expanding out to other forms. So can you explain a bit about the Nodeless, like the different forms of Nodeless?
Yes. So the idea with Nodeless is not is to have a way to interface with Lightning, use Lightning as the protocol of transferring value without the need of running a Lightning node. And we started with Liquid. The Nodeless underlying implementation is actually a Liquid wallet. And if you wanted to do a Lightning transaction, you did an atomic swap from Liquid to Lightning. And if you wanted to receive value in Lightning, you actually were swapping Lightning to Liquid. So the funds were held in LBTC. And the problems of doing that is the fact that you're relying on LBTC. LBTC is not Bitcoin. It's pegged Bitcoin to the Liquid network, and there's no unilateral exit. And with the latest iteration of our Nodeless SDK, we offer Spark integration, meaning the underlying implementation. By the way, developers are kind of completely oblivious to the underlying implementation. Technical user can choose Liquid, can choose Spark, but the interface, the developer interface is send payment, receive payment, send and receive. That's kind of what developers
They don't
need
pick
to
which one they go with?
They can
Okay,
pick,
yeah.
and we expose the optionality. But I'm just saying from an interface standpoint, Liquid and Spark aren't really exposed. It's the underlying tech that facilitates the transferring of value. So in Spark, the cool thing about Spark is that you have real instant settlement. Spark isn't a blockchain. It's a federated state chain technology. So the value transfer is instant. There are no minimum amounts.
Oh, so you can have like one sat.
One sat. It's perfect for zapping.
Yeah.
And you have unilateral exit. So I think this is a huge advancement over what we offered with Liquid. And we're also integrating, we don't have that released yet, but we're also integrating with Arkade. So people will be able to choose Spark versus Arkade versus Alpine versus whatever.
Maybe we can just elaborate a little bit on Spark, because I think people haven't really heard a lot about it. It's kind of one of those things that, it's out there, but it's maybe not as well understood in the Bitcoin pleb, let's say, world. So my understanding is it's kind of like taking like Ruben Thompson's idea of state chain, and then that was integrated into Mercury Layer, which was another kind of project, another wallet, which was a state chain thing. And then now the Spark guys have taken that state chain and made certain tweaks to it that allow kind of certain different trade-offs,
that
but
made it usable, basically.
Right. And because I think in the older Mercury Layer style, it was like you had to send a set denomination.
Yes.
Right.
Yes.
Whereas in the Spark context, you can actually change that denomination.
Yeah. So I think the innovation, the second iteration of the next generation state chain model that Lightspark and the Spark team were able to innovate, it's twofold. One is the ability to use any amount when you do a transfer. You're right. In the old Mercury model, you have a fixed amount. So if I wanted to send you 1,100 satoshis, I need to send you a 1,000 note and 100 notes in order to send you that value. And in the Spark model, the amount is variable because they switch from a fixed UTXOs to a tree model where, for example, I have 1,000 satoshis and I want to send you 300 satoshis. I take the 1,000, split it to 700, 300, and then I'll send you the 700 satoshis. State chain at its core, it's the ability to switch signature offline. So switching signatures of what? And the Lightspark and the Spark team figure out a way to dynamically create this artifact of a leaf where I can switch the signature for dynamic amounts. that's a great innovation on top of the first generation state chains. And I think another important innovation is the federated model of operators. So there's not only a single operator that you trust in order to switch the signature between the sender and the receiver. You're actually trusting, the trust model is one of n operators. So it's enough to have, so they figure out a way to build a state chain with multiple operators, and it's enough to have one honest operator for the entire thing to be trustless.
Yeah. Now, probably the more controversial aspect of that, I'm curious to hear what your stance on this is the privacy element, because this is something where people have raised that basically people can dox the entire transactional balance once you've shown a Lightning address in the Spark context. So what do you see there? Is that going to improve in future? What do you think?
I think that's part of Bitcoin politics. Basically, people take a look at Spark and they don't judge Spark by its technological merits. They judge it by some kind of a facade. They don't like to work with an American company, or they think David Marcus is CIA or whatever. I think from a technology standpoint, this is BS, and I'll explain why. So the design decision behind Spark is to expose the data of the Spark operator publicly. So all the data that is exposed to a Spark operator is available to a public indexer. So when you send a Spark transaction, the Spark transaction is, you can see the Spark transaction in an indexer exactly like you see it in a blockchain, like you see an on-chain transaction in a blockchain explorer. The problem, and it's a very tactical problem right now, is that some of the Spark SDKs are reusing addresses. So if a Spark address can get leaked, then you can see the entire balance of a user in this public indexer. But there and there are multiple ways to solve that. We already mitigate that in this Breez SDK by not exposing Spark addresses. Meaning Spark addresses are not available in Lightning invoices. It's not a good enough solution because it's prone to timing attacks. I can send you a specific amount and then see the specific amount in the Spark Explorer. So the next mitigation is to hide transactions from public explorers. That's actually coming out this week. So you won't be able as a user to see information if I don't want you to see it. The second mitigation is dynamic addresses. So all the SDK will convert to a dynamic address model. And once that happens, the Spark privacy will be on par with on-chain privacy. And the next iteration will be to do confidential transactions.
Oh, interesting. Okay, yeah, so it's interesting. It's certainly a quickly evolving space. Now, can you touch on, like, I guess the fees that end users will pay, or the fees that the builders will pay? Like, can you just explain a bit about that, or I don't know if you can touch on that.
So Breez in general, there's no added cost of using Breez. You can use us with you can use the liquid implementation without additional cost. You can use the Spark implementation without an additional cost. It's a B2B2C model, meaning the end user is paying for the transaction, and we are doing rev shares either with Bolts or with Lightspark. That's basically our business model. So it doesn't affect the end user. We're basically bringing traffic to these networks. The fees are different between the implementations. In the liquid implementation, you're paying 0.1% to send, 0.25 to receive. In the Spark implementation, you're paying 0.25 for both.
Excellent. Yeah. So look, I'm supportive. I think it's a great idea that you're out there building and making it easy for other apps and other wallets and other people to integrate Lightning payments. And under the hood, actually, there's Liquid and Spark, and in the future, Arc coming there. So I think that's really interesting. Are there any examples or interesting ideas people have had on what they could try to integrate with?
I actually was traveling so much, I haven't had time to see the submissions. I know people are integrating the SDK into quite popular open source implementations. So we have games, we have messaging apps, we have events platform applications. So really, when you think about the possibility that value transfer can unlock, it really can be integrated into any mainstream application. That's kind of the mindset shift and the paradigm shift that we want people to make. Like any app that brings users together can start to facilitate value transfer. So the possibilities are endless.
Yeah, I mean, I'm supportive. I think this is really cool. Just explain for people, what's the timing of this time to build? Like, when does it finish?
So we have until November 16 in order for people to do the integration into open source application. We give them about a month till mid-December to work with the maintainer in order to get the PRs merged. And the winners will be announced on January 8th.
Fantastic. Well, time to build. It's time to the number build.dev is the site. So listeners and people, go and check it out. And support what Roy's doing. He's doing a great job building and expanding Bitcoin. Of course, if you're a Bitcoin maxi, you should support him. So thank you, Roy.
Thank you, Stephan.
Hello, everyone, and welcome back. We are here on the Plan B forum, or Plan B podcast, rather. And I'm your guest host. My name is Stephan Livera. I'm joined today by Marco Argentieri, although I know him as Tiero. Everyone in kind of Bitcoin land just knows him as Tiero, so I'm just going to call him Tiero. Tiero has done a lot of great work on Ark. He's the CEO and founder of Ark Labs, and they have recently just announced and pushed out the public version of what's called Arkade. And you guys just had a big Arkade day. So just give us a bit of an overview. How did Arkade go?
First of all, greetings, and thank you so much for having me. It's always a pleasure to have a conversation, Stephan. And yeah, Tuesday we had an amazing day. I like to call it a family gathering, where we brought on board friends, partners, and yearly startups building on what we are doing all together here in Lugano. And we also announced to the world the public beta, so anyone can use our wallet, can start using API, developer can start looking into integrating Arkade in their application. And has been a great day, great reception. Everyone was not even expecting the amount, not only of vision and mission, which we reiterated with all the participants, but most importantly, other company and design partner were able to demo live their application, and everyone was very happy to see that coming live.
Fantastic. So let's just, this is a new concept for a lot of people, so let's try to take it simple and make sure people understand what this is. Now, I'm going to give the 80 IQ my simple understanding, and then you correct me or elaborate a bit. So my understanding is, with this Ark idea, it's like you're taking UTXOs and they become VTXOs, virtual transaction outputs, and these are kind of living on a quote-unquote virtual chain, and you can transfer them around without hitting the main chain. That's kind of the idea. And so the idea is, you could be a merchant and you could be earning and spending, but actually what's happening in the background is there's VTXOs, and there's some complicated stuff around like expiries and things like that. But if you, the end user, you just have a wallet and it just looks like, oh, I received money or I send money. Actually, in the backside, there's like swaps going on and things like this. But to you, the end user, it just looks like you just earn and spend, but there's maybe some additional functionality and features that are being enabled by Arkade Script. And then you have like an Ark, server or operator who's kind of, so maybe you can elaborate or tell me what am I missing there? Yeah.
Yep. So first of all, I think Arkade operates in a client-server model, which means you as a user, you're a client, then you have like a set of one server, most likely a set of operators you connect to, and you push all the complexity of Bitcoin transaction or making Bitcoin transaction to the operator, but you retain the simplicity of just having a simple wallet. And just to understand, like if you are used to a normal Bitcoin wallet, you have an address, you give it to someone, anyone can pay to you, right? This is a very basics 101 of how Bitcoin works, and we mirror that in the virtual layer. So you have an Arkade address, anyone can just take it, send it. You don't need to be online, which means, I'm sleeping and someone sent to my address, I wake up, my client will check the set of indexer and, show the balance to the user. So it really, really makes the same easy of developing a wallet or developing an application the same way on the Bitcoin blockchain, but you're doing in this virtual layer that Arkade enables. Now, as we can imagine, to make this, let's say, to have better property than the blockchain, so we don't need to wait for the next block, so we reduce the block time and block space constraint, there is some complexity in doing that. And historically, how internet scale, or I will say how the internet and web application flourish is only when, virtual machine has been introduced, which allowed, e-commerce and yearly website to just focus on their application and not focusing on the real complex server, machinery, data center that was being totally delegated to an operator. Now, this is an analogy just to go back to the concept of Bitcoin, and this can happen, and actually custodian, we're doing this. We're like giving away all the complexity of Bitcoin, but they were just like trading off with custody. And the beauty of having Arkade is like we try to retain as much as possible with a degrading trust assumption, but we try to allow the user to start to retain as much as possible the Bitcoin security when it's possible. We do this thanks to transaction batching, and historically, we needed compression algorithm, we needed MP3 to make sure we could get the iPod, right? And that's what we are doing, really. So we try to make sure the businesses, the operator, the startups will think about it, how to take your Bitcoin transaction, batch them, compress them, and putting on the Bitcoin blockchain, still giving you as much as possible the Bitcoin security.
I see. And so as you mentioned, still maintaining Bitcoin security. I think that's the key point that a lot of people want to hear. They want to hear this, I still want unilateral exit. That's kind of the, I guess, key feature that a lot of people are looking for if they want to be able to call it kind of a non-custodial or at least, close to self-custodial experience. Now, you touched on this batching thing. So maybe let's dive into a little bit further into that. Like how exactly does the batching side of things work? That it's like, now I understand the end user doesn't think about this, but when he, let's say he scans let's say you have an Arkade wallet, I have an Arkade wallet, I scan your QR and I want to pay you, whatever, 10,000 sats, whatever. Can you kind of walk us through what the batching looks like there?
Yep. Yeah, absolutely. So the idea is I give you an address, you will give you this virtual UTXO, which is like something that at some point anyone, your wallet, can go to the blockchain, broadcast a series of transactions, so it's not just one, a series of transactions to actually transform that just by the fact that this is a pre-signed chain of transaction in a real UTXO. But of course, we don't want to do this, right? Because it will always consume the block space. You will always need to wait for the next block time. So what we do, we leverage the operator by taking a VTXO, attaching that is already owning, right? The sender already has a VTXO, ideally batch before. It will just attach an extra transaction to that, and will have a set of inputs, which is spending the VTXO of the sender, and then I will attach a set of output. This output is like actually me, the recipient, my own VTXO. Now, we call this pre-confirm just to make really clear that this is like something that the operator is adding a signature, so it's better than zero confirmation. It's better than unconfirmed, because it's putting a signature, is actually like locking that sequence of transaction, but still you have some trust assumption from the previous spender and the set of operator to not collude and double spend. But this is important because it creates a queue of like intent of where you want to go. So as a recipient, I go online, I see, okay, I have a payment to me. I was offline before, so I get that crazy, nice user experience, and now it's on me as a recipient to decide what they want to do. I'm okay to remain in what we call the virtual mempool, and I stay there. I can spend it right away, right? So I can send it to someone else and literally like removing my trust assumption. Or no, I want to go in an ownership stage, but you don't need to exit from the system. You can stay in the system, retaining all the compression advantage, and you go to batch in the next block. So in a way, you need to wait at least the next block to get this batching aspect. And why we say it's important being batching, because no matter many users we get, it will always be better from a cost perspective, because more people, less the cost of that single Bitcoin transaction that can compress potentially tens of thousands of virtual transactions.
Okay. And so when we're talking about the unilateral exit there, is that a high cost to exit? Like, so I guess what I'm asking is, do you need to kind of have a big enough balance to make it cost effective for you to do, if you really wanted to do the unilateral exit? Or otherwise, if you kind of stay in the VTXO virtual chain, maybe you swap out not with a unilateral exit. Am I understanding you there, or what?
Yes, as everything in life, there are trade-offs, and sure, you have a cost to exit. So there is like what we call a dust amount. Like in the Bitcoin blockchain, there are like some amount of UTXO that like not economical to be spent. We retain the same property. That's like really mimics the same approach, and it will always be dependent on the blockchain. The interesting aspect is you can actually like make sure to use technique like congestion control to potentially make sure it's predictable, your exit cost, trading off maybe some time. Maybe I need to wait 3-6 months, but I know I'm trying to pay the minimum amount possible, so we'll try to be even more efficient in case of a mass exit. And how I see a mass exit is like a class action, right? So if you are a consumer against a big company, you need to cooperate with other consumer to get out, right? So to pay the big lawyer fees, and I see in the same way. The other aspect is like, this is a very remote case. Unilateral exit has to be there as incentive to not to happen. So the operator are incentivized to follow the protocol, because in worst case they just exit, right? So there's nothing to gain for the operator, which is in the end very similar to even mining, right? So mining has this like economic incentive for us to not reach that 51%, even though like already with the 5 mining pool that are out there, right? So it's really like kind of a tricky situation. So there is nothing in life which is like totally cryptographically trustless. There is a game of incentive.
Yeah, fair enough. But I mean, do you have like a rough, I guess, rule of thumb for when it makes like above what threshold?
Dust amount.
Oh, so it's just literally okay, right. Okay, fair enough. Now, I know using Arkade Script, so maybe we can get a bit of an intro on that, and then you can do more with Arkade Script. So can you just maybe give us a bit of an intro, just a basic overview? What is Arkade Script?
Yes. So in our journey, Ark has been formalized this spring. We did a partnership with the University of Vienna, with the department of Matteo Maffei, which has been, leading the game theoretical department of the University of Vienna. And with them, we've been spending time having an academic approach to try to formalize what was just a prototype we've been building in the last 2 years. And we came out with the conclusion that in the end, what we are doing is, yes, creating a system on top to not only just improve payments, but most importantly, you can take any type of Bitcoin script that you are using on the layer 1 and in a way lift it in the virtual layer. And it came out that like when we wanted to add Lightning interoperability, we need to mimic the same approach of the base layer, which is HTLC, right? So hash locks, which are very important to do what we call summary swaps, right? So I give you a VTXO and you pay for me in an atomic way. And that's a very important primitive. So we started, researching how to do that, and we saw a pattern there. And we saw that in the end, we need an interpreter. The operator need to run an interpreter, which is what, any Bitcoin full node does. When you broadcast a transaction to the normal mempool, your full node, to accept the transaction in the mempool, it will execute that script, right? Opcode by opcode to say, yes, it's valid, boom, I relay to the other node in the mempool. And we said, okay, there's a pattern there, right? So since a VTXO is basically, what is a VTXO? It's like a 2 of 2, right? You and the set of operators. And then you have a unilateral exit, which is just you, but with 24 hours of delay to allow the game of theory to work. And we said, well, an HTLC usually is like 3 paths, right? Cooperative, refund, unilateral, and claim with the pre-image. In a virtual way, we just need extra 3 more paths to mimic this, right? So to keep the unilateral HTLC and then the cooperative HTLC to be executed right away. And this is a pattern, and it's applied to multisig, so we can do multisig, we can do escrow, right? And they said, okay, this is way bigger than just like, okay, maybe we solve the payment or the onboarding for Lightning wallets. And when I started me in Bitcoin, I remember I was helping many people to get onboarded via cash, and etc. People were coming to me with escrow. With zero IT knowledge, were coming with me with the yearly wallet, having a 2 of 3 with an escrow because they didn't trust me maybe at the beginning. And it's fun because after 2017, nobody was using any more escrow. One is a great primitive to do many type of application. And that's why for us it's like, oh, okay, wow, if you can scale Bitcoin script, you can do better. Now, we keep going on because we think that pre-confirmation is a good trust trade-off. There is some reputation aspect, but we did a lot of research to try to use hardware security, like secure enclave, so that as operator, I'm using this hardware cryptographic attestation of what the software is running. So this way we can prove that actually the key is generated in the enclave, we don't see the key, we can have end-to-end encrypted from the client to the enclave, so the operator doesn't even see the intent, so improve also censorship resistance. So we did that to improve the security model of pre-confirmation, but it also turns out that like, well, we already are an interpreter, and people really want covenants, what they're called smart contracts. Why we don't add more, why we don't extend our own interpreter? We don't need to ask, the consensus of the Bitcoin layer 1. We just add more opcodes, which maybe can be a way for developers and startups to see the future of Bitcoin with covenants, so they can come. And the other aspect is like, even if tomorrow we get covenants, which will make Arkade script way more inherits the Bitcoin security, you're not going to wait 10 minutes, for a trade. You're not going to wait for the fee bidding war in the mempool. You still want to do those smart contracts in the layer 2. So in a way, like, we're already doing what, even if Bitcoin gets the covenants, you already want to do it on a layer 2. So I think it makes sense to do it now. Of course, with some trust trade-off now, because you will not be able to execute those on-chain contracts on-chain because those opcode don't exist. But the security trade-off and the security guarantee that you are doing anyway, even if you're not adding this extra script, is worth to add extra code. So developer and startup, they can mitigate their own risk, right? So they don't need to ask permission. They can just experiment, and eventually the market will tell if it's a good trust trade-off for them, for their business and their use case.
I see. So as an example, there are other builders in the space, like I've seen Philip from Lendersat. I was chatting with him earlier today, just briefly, and I think they posted something as well. Maybe you can explain a little bit about what they're doing using Arkade script, just as an instructive example for us.
Yes, it's interesting because, first of all, Philip is one of the best builders in the space, and been working with him in the past on Liquid and many aspects, and we always had the nice, we think alike, and we think, you need programmability if you want to create new type of businesses, new type of platforms. They made Bitcoin more useful in the end. And when we were discussing about, the potential to do much more than just payments, I was very interested to explore and to be one of the first design early partner. And Tuesday at Arkade Day, he surprised all of us. He was coming from Australia, so very far from here, and literally coded. He's a machine. He coded, what he demoed, which is like one of the first loan. Right, so we do a simple 2 of 3, so it doesn't require any Arkade script. So very basic, just to demonstrate like just simple primitive, but reducing block space and block time constraint is good enough already. It's really improve these programmable use cases, and the demo in front of everyone how to get an instant executed loan with sub-second execution, and he also demoed a liquidation happening in a batch way, which is the most important thing, because if you really want to have non-custodial loans, and we cannot execute thousands of loans like banks. They do every second. They do thousands of loans, but the blockchain will not
handle that. Obviously,
that.
Yeah.
So I think it was very interesting.
Yeah. And can you just explain the loan part? Because what's being used on is it a stable coin or what's used on that side?
Yes, they already run. Lendersat is a platform that allows you to lock your Bitcoin in an escrow, 2 of 3. So there is like the borrower, the lender, and a mediator, an arbitrator, right? So which is only used in case of dispute. And the idea is like once you do that, doesn't matter how it's been delivered. Your
Gotcha. Because they
principal,
could
right?
do like fiat, literally a fiat
Can be
wire
fiat,
or a
can-
stable coin or whatever. And then
Exactly.
the idea is that between the borrower, the lender, and the mediator, they at the end of the contract, or if the liquidation happens, then they'll kind of resolve it in a 2 of 3 style. Just
Exactly.
Yeah, gotcha.
Exactly.
And so this is an example where it's making lending, arguably it could make the lending user experience, the Bitcoin collateralized lending user experience very snappy. And so maybe there's something to that. And I know they also did something around, was it like a USDC swap out, something like this? But yeah.
Yeah, the interesting aspect is like it was so galvanized by the launch. Everybody was cheering, and in the end, the infrastructure is already there from their side to deliver stablecoin on other chains. And they said, well, if we can do simple loans, why we can do even swaps cross-chain. So they implemented a little demo, literally the night after the launch, and this just goes to how simple it is. For someone that already is building Bitcoin application or is already using Bitcoin script, is already knowledgeable about Bitcoin UTXO model, for him, having a VTXO is really one-on-one mirror. So, and I think I'm very, very happy that they leverage this.
So zooming out a little bit, can you explain for us, like, what are some of the categories enabled by this Arkade script? So lending is one example, obviously. What are some of the categories that you would... Of course, it's early days. It's hard to exactly know where is the product market fit. But can you just explain some of the categories that you see Ark and Arkade script working with?
Yes, of course, it's very hard to predict where the creativity of builders will go. But I really very focus on three use cases. First, indeed, is Bitcoin lending. I think the ability to use Bitcoin that is appreciating 30-40% per year to actually get liquidity without selling it, I think is a very crucial use case. And right now, either you go custodial to get good rates or need to bridge to another chain to use like so-called lending pool, DeFi, somewhere else. But again, you're degrading your security of your Bitcoin, right? So, and even most importantly, is not only the security of Bitcoin, but your own UTXO. You want to know where the UTXO history is coming because maybe you took local time, maybe you mined, you don't want to mix with someone else. So it's very important to have that UTXO ownership, and having this is very important. The second use case I'm very interested is the concept of non-interactive swaps. So right now, the problem of HTLC swap is like not only the free option, but they require some interactivity from the both sides. So I need to fund this contract, and then the other party need to go online at the same time to complete the swap. And this is very, it doesn't really allow to create very liquid marketplace for trading. So non-interactive swaps means, hey, I'm signing my UTXO, I broadcast, right, to the virtual
mempool. And here's the price at which a taker, so kind of like you're the maker, and let's say I'm the taker, you can sign this transaction, and I can, let's say there's a DEX, I guess it's kind of like a DEX use case, right? Yes. And then the idea is that, let's say I'm the taker, I see that, and I'm like, oh, I want to accept Tiero's offer, and Tiero can be asleep, and I can just see that and pick it up and sign it on my side, and then etc.
Exactly, and that's very important because if you speak with the active market makers, especially with pairs like Bitcoin to stablecoin, which are like pair with a very strong price, they don't need price discovery, they don't need an AMM, right? So they don't need a pool because in the end, as a market maker, I want an active market making strategy. I want to make the quote, right? But at the same time, this will improve and will make easy for Bitcoin native to connect to the intent solver paradigm, which has been very used a lot in the rest of the blockchain ecosystem.
One question I have on this though is, what if you're a market maker who wants to then, let's say you put out an offer, but then you want to change it because once you've signed it, you can't unsign it, right? How does that work?
Yeah, there are many ways. Of course, these are more like a category of non-interactive swaps. Depends how you implement. We did a prototype, and I think the interesting aspect is to flip the condition, so to remove the free option this way. So me, as a user, will be me to lock in an offer. So I will take a quote off-chain, out of band. I will go to a market maker, hey, give me a quote. And at that moment, we'll say, okay, I'm now broadcasting to the virtual mempool right now my funding. And it's like, you don't need to cancel, right? So if I need to cancel, I will need to pay another transaction to cancel again.
Okay.
We're not on chain, so there is no cost or virtually very little cost to execute a cancel transaction, right? And it will be instant. But this way, very important because remove the free option problem for the market makers so they can have lower spread, and most importantly, it will be better for them to have
That's sort of like a design question of how you structure it from a security and an operational standpoint. Okay, so number one, lending. Number two, non-interactive, I guess, swaps or DEX. What was the third one?
I think something I'm very, very interested is about synthetic asset.
What's that?
Synthetic asset.
Oh, okay.
So the idea is, if right now I just want to use my Bitcoin to potentially speculate on anything, I will need to, I don't know, I want to buy some stocks of some company. I will need to off-ramp my Bitcoin, go to a custodian, and basically buy these stocks in any of those platforms. And that maybe, of course, use a regulated, most likely a platform, because that's how stocks works. And then maybe I sell it, I make my profit, and then I need to sell it back, go back to my Bitcoin, right? So this is like my use cases, right? So it goes beyond just payment. But like in the end, I just want to speculate on the price. So why I cannot buy with my Bitcoin a synthetic Tesla or a synthetic Apple, just to speculate on that price or go long or go short. And I think and I don't want to use real world asset, right? Or even just a Bitcoin backed stablecoin, which has been a dream for many early adopter. And I think that will be a use case will allow to make Bitcoin use more, right? So we don't need to buy more treasury to maybe create a dollar version denominated, but I can use Bitcoin with an over collateralization and a set of Oracle to basically loosely track the price of that real world asset. But this way, this asset doesn't goes in any regulated platform, but stay in the Bitcoin ecosystem.
Interesting. And so that could be, so I guess in that, I'm trying to understand how that will work. Is that kind of like, sort of like a DLC, but with an Oracle to a stock price, as an example?
Exactly. The problem with DLC is like you have an idea interactive setup, and also you need to pre-sign and pre-set up all the exit possible path, which people like exactly like Landasat, they were building 10.10.1 before, and literally was this, right? Going long or short using DLC in a Lightning channel, and you can ask them how a nightmare was in terms of developer UX, but most importantly, the UX that the end user was having. So if you can remove that and move it to the virtual machine, the complexity, and you go in a non-interactive setup, they can focus on their business. They can focus on the platform, on the user experience of the user, and not like trying to fix the interactivity problem on that side.
Yeah, okay. So, and so I guess we've spoken about some of these different uses, but of course there's just kind of the vanilla, like just merchant adoption or just payments. Like this is now also a lot simpler, right?
Yes, it's interesting because in August we went to Baltic Honey Badger, which is one of the most a reputable conference on the block. I've been from the early days, and they used from the early days to go to all their merchant, the food trucks out of the conference, and you can buy with Lightning. That's from the early days. And many of these merchants always, had always many problems, and most of the time they need to have a custodial Lightning payment processor because the merchant just want to get payment. They don't care much about that, right? So what we did was a little hijacking of the point of sale of the Lightning, and we didn't send to anyone. So we went to them, we put basically BTC Pay Server, we built a BTC Pay Server plugin for Arkade, and the idea is like the merchant will accept in Lightning, everybody paid, and for those 2 days, nobody knew it until the very end, and everybody was paid with Lightning, so to show the interoperability of Lightning, but in the end, the merchant were getting through Bolt's atomic swap, they were getting a VTXO instead, which means they just had a key, basically. Very easy, no inbound liquidity, no channel, no node. And it was very nice because in a way we demonstrated how Lightning and Arkade can actually work together and improve one another. And at the same time, we make, finally, for commerce and retail, we bring Lightning also at that level.
So yeah, so it makes it, as I understand then, it makes it very easy to just have like a just works style wallet. You can just earn and spend VTXOs, and in the background, yeah, there might be Lightning swaps and things like that, but obviously you, the end user, you don't have to worry about that. So all the swaps and things can happen, and then theoretically, people can even use that VTXO to swap into in and out of like Tether or something else. So let's say it's a merchant who wants to take Bitcoin, but maybe they only want to hodl, let's say 10%, and they might have to swap some into Tether because they've got to pay their bills and whatever. So can you just walk us through what that would look like then on like swapping in and out of stablecoins using VTXOs?
Yes, the interesting aspect of the UTXO model, which also means VTXO model, is we can chain transactions. So imagine the Lightning swap is coming in, so it's creating a new VTXO, but then the merchant right away at the same moment, so it doesn't want any spread, any volatility, he wants right away swap it with another market maker. So in the same moment, the plugin could like contact, this market maker and say, hey, there are like let's say 0.1 BTC coming in. Are you giving me now at market rate USDT? And you can chain that swap. So that VTXO will right away fund a swap and receive also USDT in a VTXO on that side, which will allow, again, the merchant not have any volatility, simplify the accounting, and eventually maybe he can also chain again, and maybe just with the profit, right, buy Bitcoin, right? So the model will be, well, up to the profit, I will just retain that. So you will do 3 transactions, which on chain will be expensive, but now you can do it everything in the virtual mempool right away, and you execute everything at the same sub-second, confirmation. So which is, again, programmability solves the problem of payment processor, software as a service, which are the one that actually will allow merchant and retail to use Bitcoin, because like everybody focus a lot on the payment side, right? So on the sender side, oh, I want to send it, but nobody speak or think how a payment processor want to actually operate those Bitcoin payments. And I think it's very important to have this programmable flow to allow even something that I really care about myself to pay with my Bitcoin and live with Bitcoin as much as possible.
Yeah, it's fascinating because I was at the Baltic Honey Badger we were just talking about, and I made a Lightning payment. And didn't realize there was kind of Ark in the background until I think Giacomo told me, and I was like, oh, that's interesting. And then next time I went to pay something, I looked at the terminal, I saw it had the Lightning side and an Ark side. So if you wanted to just direct pay with Ark, with an Arkade payment. So I thought that was really cool, that it was like just kind of seamless, and I think it leverages a lot of the experience that Mr. Cooks has. Mr. Cooks is on the team with Ark Labs, and Mr. Cooks has a lot of experience in BTC Pay. So for a lot of people who don't know, he was literally on the ground working on these like merchant adoption cases, as well as trying to help with a project he had called Transmuter, which was a plugin to try to help swap some Bitcoin into fiat and so on. And so it's kind of funny that things have kind of come around full circle now,
yes.
right? That now he's working with you guys on this startup that helps people do Arkade, get VTXOs, and if they want, they can swap into Tether, or they can just hold the VTXOs, or you exit on-chain to Bitcoin on-chain, like put it in a hardware wallet, of course, self-custody, not your keys, not your coins, all the Maxi typical talking points. But it's just fascinating where this is all gone. So any kind of closing thoughts on where you see this going with Ark and Arkade scripting?
Yeah, we are in public beta, so we got a great response so far. So we are very humble, and we thank the community on this, but it's just the start, right? So it's not the end goal. The goal is really like try to reach a point where we can flip the situation where like Bitcoin is seen more than just a static asset, but actually Bitcoin is being used to create potentially a platform for new type of businesses that couldn't exist nowadays. And they will only exist thanks to a Bitcoin being used as a backend.
Yeah. Fantastic. Well, I think that's a great spot to finish up. So just before we finish up, where can people follow you online and keep up with what the team are doing on Ark?
Yes, I'm Tiero on X. Arkadeos.com is our website. So you can find documentation if you're a developer. You can find also our web wallet if you want to experience our beta. And yeah, leave a comment. Help us grow so we can make Bitcoin better.
Fantastic. All right, guys. Well, that's it. Make sure you check out Tiero and what the team are doing at Ark. Everyone, please put your hands together for Tiero. Thank you.